Good afternoon, sir. My name is Saliha Surati. In this video, I will be explaining question 2. I will begin by explaining the different types of lines. I will be describing a ray, parallel lines, a segment, and perpendicular lines. So a ray is described as part of a line. It has a fixed starting position, a starting point, but no end point. It can go up until infinity, and while going to infinity, it may pass through multiple points, but it will never have an end. A parallel line is a set of lines on a plane that always has the same distance apart. Because they are the same distance apart, they will never meet or cross each other ever. A segment has two endpoints and the length is fixed. It cannot be changed. The length of a segment is the distance between the starting point and the end point. The length of a segment can be measured using any metric units, example millimeters, centimeters, or inches. And lastly, a perpendicular line. Perpendicular lines are when two lines are crossed, they will intersect in the angle, and it will cross at a 90-degree angle, otherwise known as right angles. When they are crossed, they will always intersect, and the angles will always be a right angle, and it will always measure 90 degrees, because this is what a right angle is. If two lines are perpendicular on the same line, they are parallel lines, and they will never cross and they will never intersect. Thank you. Next, I will describe the difference between geometric thinking and what my understanding of geometric thinking is, as well as spatial thinking. So geometric thinking is how we use properties of shapes, and it is also linked to spatial thinking. It is how we develop an understanding of geometric relationships and how we differentiate between shapes and their properties and objects, and it is also having the skills to classify these objects and shapes. Spatial thinking is having developed skills so that numbers and relationships become a sixth sense to you. Having intuition about shapes and their relationships is what spatial thinking is. When we have spatial sense, we have a feel for geometric aspects in our surroundings and the objects formed by objects in the environment. I will now be explaining the properties of the following shapes and how they differ from each other. That is the rectangle, square, rhombus, parallelogram, kite, and trapezium. To do this, I will be showing you a table. A trapezium has only one property, and that is only one pair of the opposite sides are parallel to each other. I will first be explaining the properties of these shapes. So a rectangle has three properties. All the angles of a rectangle are 90 degrees. The opposite sides of a rectangle are equal and parallel. That means they will never meet, they will never intersect. And diagonals of a rectangle bisect each other. The properties of a square is all the angles of a square are 90 degrees. All the sides of a square are equal and parallel to each other. Diagonals bisect each other perpendicularly. This means the square also has three properties. Next is a parallelogram. A parallelogram has four properties. Opposite angles are equal, opposite sides are equal and parallel, diagonals bisect each other, and the sum of any two adjacent angles are 180 degrees. Next is a rhombus. A rhombus is a quadrilateral which has the following four properties. Opposite angles are equal, all sides are equal, and opposite sides are parallel to each other. Diagonals bisect each other perpendicularly, and the sum of any two adjacent angles are 180 degrees. From my table below, the ticks indicate how they are similar to each other, and the crosses is how they differ from each other. So as you can see, we have the sides. All sides are equal in a square, a parallel only in a square, and a rhombus. Opposite sides are equal in a rectangle, a square, a parallelogram, and a rhombus. Opposite sides are parallel in a rectangle, a square, a parallelogram, and a rhombus, and a trapezium. Angles. All angles are equal on a rectangle, a square. Opposite angles are equal on a rectangle, a square, a parallelogram, and a rhombus. The sum of two adjacent angles are 180 degrees in a rectangle, a square, a parallelogram, and a rhombus. Diagonals. Diagonals bisect each other on a rectangle, a square, a parallelogram, and a rhombus. And they bisect each other perpendicularly only on a square and a rhombus. As you can see, a trapezium does not have much in common with any of the other shapes, besides the opposite sides being parallel to each other. I will now explain the final question, which is how to use manipulatives and activities to enhance students' knowledge and skills about shapes. So the manipulatives that I would use is pattern blocks. They come in various shapes and colors. And so these can be used to explore spatial relationships. While learning through play, students can enhance their ability to recognize similarities and differences by duplicating another student's patterns. As we know that students at foundation phase level will copy what their peers are doing. Therefore, they will be copying their friends' work, and while doing so, they'll be able to recognize the similarities and the differences. Another manipulative that I would use is geoboards. These are excellent for teaching geometry. We can create different shapes by stretching rubber bands over pegs. It is a manipulative used to teach perimeter, symmetry, and angles. Using this method makes it easier for younger students to understand difficult concepts. I can use a geoboard to show a square with a perimeter of 10 units. I can make rectangles of different sizes. And I can ask students to find the largest square or rectangle, and I can also make a hexagon from these geoboards to find the perimeter. An activity I can use to enhance the knowledge and skills about shapes is I can create a scape shape, a shapescape. To do this activity, it is used to enhance students' knowledge and skills about shapes. For this activity, the students and the teacher will be collecting 3D objects, example, cans, cartons, boxes, balls, paper towel rolls, anything from your household or the environment can be used. Students will use these objects to build a scape. And finally, once the scape is built, we will be able to label the scape, and we'll be able to count how many shapes was used. Example, the toilet roll rolls can be used as a foundation pillar. It can be used as a tree trunk. So we can use these shapes and we can label them and count how many shapes were used. And at the end of the activity, we can also start a discussion on how to add additional shapes to the structure. Thank you.